We can also classify functions as being either even or odd, algebraically. A function is considered to be even if f of negative x, meaning we take that function and evaluate it for the expression negative x, ends up outputting exactly the same expression that we started off with. A function is considered to be odd if we evaluate f of negative x, meaning we're evaluating exactly the same expression, but the result ends up giving us the opposite of the original function that we started off with. Keep in mind a function can be even, odd, or neither. So if those two properties don't apply, then our function would simply just not be even or odd. Starting off, what we can do is look at evaluating in part A, f of negative x, meaning we'll substitute in negative x, or the opposite of x, into our function everywhere an x occurs. And then we'll simplify. Negative x cubed would be the same thing as negative x to the third power, so our first term becomes negative 4x cubed. And then negative 7 times negative x will give us plus 7x. So what we've come up with here is not exactly equal to the function that we started off with. So we know that it's not an even function. To check if it's odd, we need to evaluate the opposite of our original function, so negative f of x, which would be the opposite of 4x cubed minus 7x. Distributing that negative through would give us negative 4x cubed plus 7x. This result is exactly the same thing we came up with when we evaluated f of negative x, which tells us that we have an odd function. For g of x, we can start off with the exact same approach. We'll evaluate our function for negative x, or the opposite of x, substituting in the opposite of x for every x in our expression. In this case, x squared will cancel out that negative, so we'll end up with negative 7x squared minus 5, which is exactly equal to the original function that we started off with, meaning this is an even function. So even though we substituted in negative x, that didn't actually change our function at all. For h of x, we'll look at evaluating the same expression, h of negative x, which will give us negative x squared plus 4 over negative x squared minus 3, which is going to be equal to just x squared plus 4 over x squared minus 3, which again is exactly equal to that original function, h of x. So what we have is a case of another even function. And I'm going to go back and correct just a minor mistake in that previous example. We were looking at g of x, so that should be set equal to g of x, that equation we started off with. We'll look at one more, where again what we'll do is substitute in opposite of x, which will give us the 9th root of the opposite of x, which we could rewrite as the 9th root of negative 1 times x. The 9th root of negative 1 would just be negative 1, so we can pull that negative out in front to get the opposite of the 9th root of x. And hopefully it's pretty straightforward to see that this is equal to the opposite of our original function, which is not h of x, but k of x. So k of negative x ends up giving us the opposite of that original function k of x. So what we have again is an example of an odd function.